a super popular platform IDE that we're going to be talking about next. This is a platform that's been in development for a year, just over a year. It's been available for 4 months. It was so popular actually that they had to close off the open first. I think you got 100,000 or so usage downloads in a short period. Now though, really happy to say it's a GA product, so Kiro is fully GA, and Al Harris is the tech lead at AWS over at Kiro, and he's going to be talking about how you can use specs as part of spec-driven development to really build out those incremental features. So pass it over to Al. Al, over to you.
Yeah, thank you. So first of all, thank you for having me, and thank you for putting me on the spot about our sort of rolled back preview release we did a few months ago. That was a fun time. My name's Al, like Simon mentioned, principal engineer at Amazon. I'm the tech lead for Kiro. I think we have Rene here today as well speaking, but he, another engineer, and I basically built Kiro from the ground up and launched it publicly, I think 4.5 months ago, something like that at this point. But yeah, GA this week, which basically means we can take money in a better way now. But other than that, I'm here to talk a little bit more about spec-driven development. So the reason we shipped Kiro was really because we believed that spec-driven development was going to change the way we interacted with AI tools and allowed us to use these tools better. So quick show of hands, who here's done something that you would qualify as spec-driven development? Maybe 50-50. So I'm going to just kind of flip a coin and say, I bet we're not calling spec-driven dev the same thing. That's kind of the starting point. Everybody has their own definition right now. Spec is an overloaded term, but I am going to slightly disagree with what Guy said earlier this morning, that spec is context engineering, or spec-driven dev is sort of equivalent to context engineering, because the way that I think of spec-driven development is your specifications become a control surface for your code base. And that's something that's been pretty fairly consistent through line for the product since we got started. So we'll talk about that in just a second, but you've heard it over and over today and yesterday, but some of the challenges with AI development, you have code quality that is sort of all over the place. You might get a golden patch one day and just have terrible experience the next. You've got limited control. You're sort of begging the agent to do something different. No, I meant this, da-da-da. And the agents do very well at small tasks, but you are on the hook for sort of breaking your task down to a small, repeatable, and understandable scope. So we shipped spec-driven dev. We took about 7 attempts to launch spec-driven development. We had various implementations of this, some that we called, I think ephemeral specs, we had hierarchical specs, we had TDD-based specs. Everything had to have the word spec at the end. But at the end of the day, we wanted you to be able to interact with your system via natural language. You can interact with a natural language representation of the system, component, module, whatever you want to ship, and the system will take care of that. What we landed on is the SDD flow that we shipped today, or shipped a few months ago, and we're evolving today. And that is that effectively your specs represent the state of the system you want to ship. So previously vibe coding effectively covered the implementation. It could really cover anything if you ask the system to, but we envision specs effectively covering the full sequence of the SDLC, and we want to bring the classical rigor for the software development lifecycle into AI development. So what is spec-driven development? In my mind, I'll qualify that. It's effectively a set of artifacts and a structured workflow. That is what we launched Kiro with, and what we're moving towards now is delivering reproducible results. So the set of artifacts we'll talk about first, but effectively, when you use spec-driven development in Kiro today, we'll push you through a workflow that produces a set of artifacts that we suggest you commit into your repo or you commit into wherever you want it to be. Effectively, this is going to be requirements, design, and tasks. Well, I'll walk through sort of what each of these is. If you were in Alex's talk on Backlog MD yesterday, there's going to be a high overlap there. But effectively, for requirements, I want to be able to prompt my system. This is not really a pitch for Kiro. I'm just showing Kiro spec mode. Let's build a CLI for meal tracking, spit the thing out, keep on trucking. And Kiro's going to go off and generate a requirements MD file for me. And so this requirements file is our interpretation of what the sort of PM in your life would have done, or if what you're going to do if you're going to break down work for other engineers on your team. And effectively, we give you a set of basically an intro, which is what is the summary of the problem you gave the customer, what is the glossary of terms. We'll talk a little bit a bit more about that when we get towards reproducible results. And then a set of requirements with related acceptance criteria. So each of these ACs is now addressable. We can reason about here requirement 1.2, which is the meal tracker CLI shall accept meal, but these requirements are effectively user stories, and then these acceptance criteria we represent in ears format. And ears is the easy approach to requirement syntax, popularized by sort of other highly governed industries, but we took it because it's a structured natural language representation of what you are saying to a system. So for people who've worked in industries with requirements engineering where that was a thing, they might be familiar with ears, but it lets us use classic non-LLM tools on top of your requirements to sort of reason about them. Again, I'm really excited to talk about that. That is a set of features that came out with our GA on Monday. More about that a little bit later. So that's your requirements, the overview, the glossary, the user stories or requirements, and then the acceptance criteria. Next up, we'll talk a little bit about taking that set of requirements and translating it into a design. So for the purposes of the demo, I think I have not changed my requirements at all. I gave the prompt was fairly straightforward. Give me a meal tracking CLI. I want something I can invoke. Maybe I asked for something slightly different in the requirements. I don't remember. But Kiro asks me, hey, are we happy with the requirements, or do you want to iterate? In this case, I just said I'm happy. Let's keep on trucking. And so Kira is going to start generating a design doc. Now, this design doc is just one template. You are free to sort of mutate it in any way you want. And the template includes things like high-level system design, modules, interfaces, security concerns, testing strategies, and the new addition as of Monday with our GA release, Kiro 0.60, or 0.60, I should say, is properties. We'll talk a little bit more about property testing towards the end, but that is effectively identifying invariants in the system, which are what are the things that are going to be true about the system no matter what, that if we can prove are met, will give you confidence that your requirements are being met once you're finished with implementation. And in this case, something else I did, and I might just kind of rewind my video here briefly, is we'll talk a little bit more about this, but at the end I think I said something like, oh, I want to invoke it. Yeah, you'll see the sample usage here was like node CLI.js arguments. And I said, looks good, but I don't want to interact with node CLI. I want to just have a named command. So minor change, but at any point in time, you're in this chat-based environment, so you can chat with your design docs, you can chat with your requirements, you can chat with your task lists. Yeah, so at a high level, that's what the design is. It's going to be the key technical details, it's going to be interfaces, it's going to be testing and security concerns, and importantly, at least to me, it's highly flexible because my opinion about what matters in a design doc may be very different than yours and yours and yours, and we're going to be working on things that are at different life cycles. So I may care much more about how a refactor project, for example, fits into the larger ecosystem of the code base, whereas if I'm doing Greenfield, it's like, skip over the details, just keep, like, let's move as fast as possible. I only want to talk about maybe the interface. Last in our set of artifacts is the task list. So Kiro's task list is the thing that's closest to backlog MD, but this is effectively given a design, we want to break it down into tracer bullets that can be implemented. Each of these tracers, again in the UI, I sort of just say, yes, please go to tasks. And Kiro's going to shepherd me through this workflow. And these, I really should not have scrolled that much while I was recording this, but it's going to give me a set of tasks, potentially nested and potentially deeply nested, though we sort of disincentivize that with the agent, which are written, they're effectively the equivalent of a Jira or of a Asana task or whatever that I would give to an engineer, and they are human readable, and they tie really crisply back to a requirement that is being solved by these tasks. There's not a ton that's actually super special about the task breakdown. Some things we've done since launch is we give you like optional tasks. So if you don't want to add, let's say you're doing something closer to Vibe, but you want to review design docs as you go, we would give you like, you could do MVP mode, I think is what we call it, where we just don't generate unit tests if you want to skip that. Additionally, with the addition of property tests, we now allow you to skip that as well. Since property tests can be expensive, at least in implementation time, although they give you a lot of confidence in what you're shipping. So that's kind of the first tentpole, I'd say, for what I consider spec-driven development to be. The second is the structured workflow. And then this is what's effectively different. I've seen a lot of talks in the last 36 hours from people who say, I do this and I do this, and like I go through things this way. And ultimately what I want to do for you is to make sure your tools do that on your behalf. And you don't have to be an expert operator to have good results out of your tools today. So this is kind of a silly diagram, but effectively, the workflow we just walked through is a very simple example. It's 3 nodes in a graph, and at each node, you can always hop to this like iteration loop and go back. Now, what's not documented is the fact that you're in a very flexible system. At any point in time, you can just hop back and start tweaking requirements, tweaking design, tweaking tasks, whatever. So we do try to keep things very flexible. We don't want to be too rigid, but we do want to move the LLM and the agent itself, I should say, through this structured workflow on your behalf. And then finally, this is the thing I'm the most excited about, is the reproducible results. So there's, I think, 2 things we're doing as of this release on Monday, 0.6.0. One is we reason over the requirements you provide to the system to search for ambiguity. I don't know that we surface these visibly yet, although more to come. But we will ask you questions to resolve ambiguity in your requirements layer. So let's just say, in the example Guy shared this morning, he's got a button. If the system finds that you have maybe gone through and built a bunch of buttons and you're saying, I want a blue button, or I just want a button, and it doesn't know if you want it to be like an accept or a secondary or an alert or whatever, that's kind of a trivial example, but you could come in and the system would say, hey, this is actually a fairly ambiguous requirement. We have some automated reasoning systems we run in the back end to help you define these things or identify these things, and then the agent will actually help you winnow down that ambiguity. So that's step 1. Step 2, we highlight the critical decisions in the design, and we will circle with you until we are happy with we understand those decisions. You've made a decision, or you've said, I don't care, agent, flip a coin, keep moving. And then third is that we break the work out into bite-sized chunks. So this is really trying to move the amount of work we're asking the agent at any point in time down to the smallest unit of work that could be theoretically committed. On the Kiro team specifically, we spend a lot of time we have a standard where you'll create a commit, for example, with your specs, and then you'll create a commit for effectively every task produced so that we can review the code piecemeal. Even if it's not committed, like pushed piecemeal, they are independent commits that'll be pushed. And now, this is the new stuff we shipped on Monday that we're really excited about. So this is an example of an ears style requirement. It's basically a subject predicate. So we have that dictionary I talked about in the beginning. So we will define what the traffic control system is, what the control module is, what all these different things that are sort of properties of the system are. And so the ears format allows me to say, while condition, the traffic control system, subject is operating, this is the state, the control module, subject, shall, predicate, maintain the invariant that at most one direction displays green. This is a very simple English sentence that describes sort of the correct behavior of a traffic light. You should, no matter what happens, any sequence of events, any sequence of interrupts, any sequence of state should only at most one direction should display green. We're okay if they're all red, but you don't want 2 green. That's a huge problem. So what Kiro's done here is it's parsed this out in your design into a property, which is a type of invariant, a safety invariant, that says that at most, 1 green signal for any sequence of operations, and then kind of all those things I just mentioned. At every point in time, at most one direction should have a green signal, and crisply we say this validates requirement 2.3. And now, like on the surface, this is not super useful. This is me just sort of reframing the requirement I already wrote, but we then go, and depending on your library of choice, we'll pick a property-based testing framework. I think for Python, we use Hypothesis. For Node, it would be FastCheck. Again, if you have a preference, you can tell Kiro to use that instead. And same ears requirement is on the left. We will produce a property test on the right. So another quick show of hands. Has anybody here done like written property-based tests? Used, okay, we got 1, 2, 3 in the back. Super powerful, huge pain in the ass. Getting these right, having stopping conditions and bounding conditions that work are difficult. It's like everyone likes BDD until you have to use Cucumber and actually implement it. I find for most teams the same thing happens with property testing. At a high level, the way to think about it though, if you're not familiar, is that you represent the test cases of your system as a set of, you effectively define the input space, which will be auto-defined by your test runner, and then you define the test behavior. So For all countable numbers, when I add them, two of them together, the result should be the two of them added. That's a bad example, but maybe when I double them, modulo 2 should equal 0. Well, I've just decomposed the problem into sort of my problem search space and the verification logic, and then systems like hypothesis for Python or fast check or whatever, kind of your PBT library. Closure spec is another one. You will go through the process of identifying sort of the universe of possible test cases, identifying edge cases, and then through a process called shrinking, which is effectively the secret sauce of any library, it will run a bunch of these samples through and try to find a single counterexample. Because all the test needs is a single counterexample to say your requirement is not being met. If you cannot find one, either one, your universe of possible test cases is bad, or two, your test is poorly written. But assuming those two things are not true, which there are patterns to address them, at the point that you have a passing property test and the property is testing the right thing in your system, you have high confidence that what you have shipped in code is what you said you were going to ship. And that is important, because this means that if I say, while the traffic control system is operating, the control module shall maintain the invariant that at most one direction displays green, and I prove that, I now have a high degree of confidence in the safety of the system I'm shipping. This is one example, but there are a lot of properties, I should say a lot of types of invariants. We have, I think, 7 classes of invariants we consider in Kiro, of which there's safety and timing and data correctness and things like that. So this is, I think, the biggest thing we shipped in the last few weeks is this property-based testing. It's very new, hot off the presses as of Monday. If you haven't tried out Kiro, I invite you to try out Kiro, give it a shot, and let us know what you think. But I've left quite a few minutes here at the end for questions.
I'm so happy about property-based testing. I'm just going to install it tomorrow and do all kinds of things with it. Thank you. Curious, one thing is you say you break work into bite-sized chunks. Mm-hmm. Do you also give the context enough? So sized context to do that, and plus anywhere they need to look at?
So the way we treat context for task execution today is that we provide the entire context of the goal. That is the design and the full task list, but that is effectively provided as background context along with all your sort of rules and norms, your agents, MD, whatever, steering files. But the task provided to the system is execute task x.y, which is make a system that does this, do not implement further tasks, do not go beyond the brief. So we provide the full context of the goal, but we are saying, which is effectively the same as like me giving a junior developer on the team, let's read the technical design of the system. You're adding the, payments widget, something like that. That's the way we're thinking about it today. It's perhaps slightly naive and something we could iterate on quite a bit.
Which models are you using, and is that user selectable? And is there any option for local models?
No option for local models, I'm very sorry. But the model is user selectable for most things. In this case, I think in the demo video, I'm using Auto, but today we have Sonnet 4, 4.5, Haiku 4.5, maybe a few Nova models, and I think we're trying to get Quen in as well. Yeah.
Property-based testing is new to me as of a few minutes ago, so I'm very happy for that. But having read what it is, the problem space can sometimes be really big, presumably, for complex systems. So, how do models deal with reasoning over trying to find the right set of constraints so that your property-based testing is valid? Like, do you run into problems there, kind of scaling that paradigm?
In some cases, we do. For example, just I think this weekend, one of the PMs testing out the product before launch said, "Hey, my test ran for 8 minutes. What's going on?" It's like, yes, that is a problem. We should fix that. It is one of the key challenges of property testing, is that anytime you have sort of generative input, your library of choice will actually have a significant influence on the performance of the system. But so that shrinking of the problem space and definition of the problem space need to go really crisply hand in hand in order to have success. So I'm going to say there's no panacea here. Probably we're going to go through a little bit of a learning period with this feature now rolling out to many, many more users, not the 100 or so we've tested it with in the past. But if you've got feedback, please reach out to us on GitHub or Discord. Yeah. Oh, okay.
Is it possible to customize how the specs are created? Like, meaning, if I wanted Kiro to call some tools to gather more relevant context before it starts generating the specs, is it possible to do that, or like?
Oh, totally. Yeah. So I've given this talk a few times in the past, so I'm giving it later this week as well, around using, for example, MCP is a good example because it's very easy to rationalize. But let's say I actually have a killer product team. They've defined all of our goals and things in Asana, and I don't want to copy things into Kiro. I can just hook up to the Asana MCP and say, like, read all the tasks assigned to me, rationalize this into one or more projects, and generate spec for it or for them. You can do that. You can use specs during task execution, MCP or whatever. That kind of comes back to the thing I mentioned a fair bit earlier, which is I want the system to be highly flexible for you as a user, which is that not just that the structure is flexible and you can kind of jump to wherever in the workflow you want to revisit, but also that you can change the design doc structure. You can change the task list structure. Task list is a little weird because we have highlighting on stuff and checkboxes exist for certain patterns, but in general, you can still do whatever you want. We're just recommending that this is sort of the best starting point.
Okay, we've got one question online, and I'll take this gentleman at the front as well. So, question from AI Native Dev Discord. How do you evolve specs or design over time? So, say that I want to change a feature shipped months ago. Do I start from a new spec? Do I take the previous spec and change it?
Yeah, this is, I think everybody you ask is going to have a slightly different opinion. My recommendation and what I do on my team, and suggest my team does as well, is that if I'm mutating something that exists, I go and mutate an existing spec. Let me see if I can actually just jump out to Kiro for a moment. So this is my Kiro. Let me use a light mode. That's not a light mode. I am going to apologize for whatever I just did. So here's an example of the Kiro extension. This is where a lot of our code is. You can see I'm playing around with Tesla and trying to integrate some of the grounding specs over there. But if I hop into, we delete specs actually fairly aggressively when they're more than a few weeks old, so you can see the specs that are actively or have recently been worked on. But let's just, for example, say I want to talk through the message history sanitizer, which is a project we have such that if you get into an invalid state at any point in time, the system will kick it out. I can easily dive in here and say, I want to add a new message history sanitization rule such that messages with a Levenshtein distance too close will be deduplicated. And so in this case, I'm going to commit my PR, which really has an amendment to the requirements. It will have an amendment or set of amendments to the design and net new tasks that get shipped out. We don't have to watch the whole thing play here, but it's going to go and find all of my specs. It's going to read through relevant specs, probably find the message deduplicator one, or sanitizer one, I should say, and then go in and mutate them. And instead of me shipping 3 big docs to my team for review, we will be talking about really diffs, which is what we are working on here. Yeah, so in this case, it's read the existing artifacts and they'll keep on trucking.
Awesome. Got time just for one more. Also, big shout out. Hello, Macy. Sorry.
Thank you. I was just curious if, like behind the scenes in Kiro, does it kind of keep like a global data of, say, data models and properties of entities, or does it actually every time go and search out what needs to change?
You mean like structurally in your code base, or?
Yeah, I was curious, like whether behind the scenes it has a map or a model of how your objects and entities relate to each other, and you store that, or is every new spec going and mining and figuring out where to add things and what to change?
I would recommend you take a look at the slides Lotta shared yesterday. Okay. Effectively, we do not do that automatically for you, but I think that would be a reasonably easy thing for you to do with memory or steering.
Yep.
If you haven't played with steering, we have, I mean, it's memory, it's, Claude's context, whatever. But yeah, you can do a lot by just saying, what did you learn from this interaction? What do you want to remember for next time? Put it in a steering doc so that you can reload.
Cool, thank you.
Yeah, thank you so much. And thanks for the patience. You were like second person to raise your hand. Thanks, Al.
Awesome. Thank you very much, Al. And yeah, Al is here. So if you didn't get the chance to ask a question, it's lunch now. So don't let Al eat. Just keep asking him question after question after question. Al, thank you very much. Pleasure.